Okay, so today is the first class of trigonometry for AS, and this trigonometry is very different to the trigonometry that you did before in your O level IGCSEs. In your O level IGCSEs, you did the simple SOHCAHTOA. You were more concerned with the geometry part. You found the area, you found the length, you found the perimeter, and you worked with trigonometry in terms of triangles. You found the Pythagoras. You used the Pythagoras theorem and you found the height and the base and the area and perimeter, all of this. Right now, this is the more, what do you say, the basics, more pure trigonometry that you would work. So, first of all, but everything, this trigonometry will also revolve around the sine, theta, cos theta, and tan theta. These are the three basic trigonometric ratios. Three basic trigonometric ratios, and we know that what are they? Sine is equals to opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. And how do we relate them all? Using a simple right angle triangle. And if this is theta, oh, sorry, this is 90 degree, this is your theta. So we know the side which is opposite to the angle that you are talking about, that you are considering right now, that becomes the opposite. This one would be your adjacent. And the side which is opposite to the 90 degree always becomes your hypotenuse. And hypotenuse is always the largest, the biggest side of the right angle triangle, hypotenuse. And hypotenuse also, we know the hypotenuse square is equals to base square plus perpendicular square. Right now, this Pythagoras theorem you won't use it in the pure trigonometry chapter, but you would use in the other trigonometry other chapter as well. Secular measure, you would use the geometric part of trigonometry. There would be needed. But right now we work on the angles. Right now we are more concerned with the in this chapter you are more concerned with angles part and the graphs of sine, cos, and you have done a bit of these things in your IGCSEs, but right now it will be much more in detail, properly everything, the basics, and your basics in AS will reflect your preparation in your A2 trigonometry. Everything from here will be connected. Whatever you would do in your A2, your AS trigonometry should be very very good. That's when you would do your A2 then very easily. Otherwise, you would have to do the AS trigonometry also again. So So we know that these are the three things, and how can we start now over here? First of all, with a simple example, how can you find the exact? For example, they've given you this triangle, and they have given you that. No, no, wait a minute, not this. Okay, the question is given that sine theta is 5/7, and that theta is acute. Find the exact value of cos theta and tan theta. You can do this by calculator as well, but we have to understand how these three things are connected. The sine, cos, tan. We know that these are connected by a right angle triangle, by a right angle triangle. So how will we do this thing? Manually or without the direct using a calculator. So this question has three parts. One of them is this thing that they've given you, the sine theta value. It is 5/7, and they have given you this another information. This is something unique. This they have given you that theta is acute, but right now we won't be focusing on this one right now. We would be neglecting or not to focus on this one right now. This is of more concern right now. Leave it right now. Leave this part. I will tell you how this will affect your solution, but in the next example, leave this right now. Right now, I want to understand, make you understand how these three are related. So we know they have given you sine theta. It is equals to 5 upon 7, which we know it is equals to opposite upon hypotenuse. So if we draw up a right angle triangle like this, any right angle triangle, if we label this as 90 degree, this is a theta. So now we know that the opposite, it is 5 and hypotenuse is 7. So this means the opposite, which is this side, opposite to the angle theta, it is 5, and hypotenuse opposite to 90-degree angle, it is 7. Now using Pythagoras theorem, I can find the base as well, this thing. I can easily find this. We know 7 square is equals to 5 square plus base square. So 49, 25 base square. So 49 minus 25 will become 14. So square root of 14 is your base. The length of your base is square root of 14. And now you can easily find the values of sine theta as well and cos theta as well. Simple. So how? Sorry, we already have the sine theta. We can now find the value of cos theta and tan theta. So cos, we know it is equals to adjacent upon hypotenuse. And now we know the adjacent, we have found out. Adjacent is this under root 14 divided by 7. This is your answer for cos theta. And for tan theta, this will be theta is acute and your tan is uh, adjacent upon hypotenuse. No, opposite upon adjacent. So opposite we know it is 5 and adjacent we know it is under root 14. So these are the exact solutions. These are the two answers. That's what they were asking you to find. So even without using the calculator, this is how you can relate the sine, cos, and tan with the right angle triangle. And you can easily get the unknown things. Easy. The important part which was new to you, which you should be more curious about, is this part. They have given you the theta is acute. Now they can give you that theta is obtuse, so you would have some different answer. If your theta is between 270 and 360, you would have a different answer. So it depends. Okay, this is the new thing that you would now learn. What do you do further? Let's do another example, and then I'll tell you how this the second part will affect your solution. If there's any questions, ask. But right now, I think this is easy, very. People won't have any question. Let's suppose it is given now that tan theta, it is 0.7. Any other value. Find the exact value of sine theta and cos theta. How would you do this one? Again, we know right now they have given you that tan theta is 0.7. So if you label this on a right angle triangle to relate them, this is your theta, and tan is opposite upon adjacent. So you can write upon 1. So you can write this opposite is 0.7 and adjacent is 1. This is your opposite and this is your adjacent. And now using Pythagoras theorem, you can find the hypotenuse. 0.7 square plus 1 square. So hypotenuse will equal to 0.7, 0.49 plus 1, 1.49, and a square root of 1.49. Zero 0.7 square plus 1, and this square root of this answer. Let's keep it square root of 1.49, exact form. So now we know the hypotenuse as well. And now we can easily find the sine theta. Sine theta is opposite upon hypotenuse. And cos theta is adjacent upon hypotenuse. These are the two solutions that they were asking you. And this is how you can relate your whatever the trigonometric ratio is given to you, the value. You can relate it with the right angle triangle, and then you can find the others as well. Simple. Any questions, anyone?
No, sir.
Okay. So now this is the new thing. Now what if they have given you that they have given you cos theta is 7 upon 10 and theta is now and the theta is between this between 270 and 360. Now how would your answer change? For this question, we have to understand, we have to bring in another concept. For that thing, we would need to do the basic quadrants, thinking about the quadrant, working on the quadrants. These are your four quadrants. Quadrant 1, 2, 3, 4. Four quadrants. And your angle, the theta, is always from positive x-axis. Positive x-axis. This is something you need to learn. So this means that if your angle is between 270 and 360, this means that it is somewhere over here in the fourth quadrant. So if you this is 90, this is now total 180, this would be 270, and between 270 and 360 is this region, the fourth quadrant. So this means that your angle is in the fourth quadrant. Now how does this change the solution? This is something new now. The values of, we have this thing, we call it cast. C A S T. Cast is, this tells you what values are positive what and negative in what quadrant. So in the first quadrant, if there's any angle theta which is in the which is in the first quadrant, all values would be positive. All positive. Which means sine of a acute angle. We know this angle is between 90 and 0 and 90, which means acute. So any acute angle. That's why over here as well, if your theta is acute, if your theta is acute, then they all of them would had a positive answer. Look, tan also had a positive answer, cos also had a positive answer, sine also had a positive answer. Over here as well, all positive. So if your theta is acute, if it is in the first quadrant, so all positive. How can I show you this using your calculator? Look, so let's suppose if it is sine 30, look, it is a positive answer, 0.5. If it is cos 30, again 0.5. If it is tan 30, again positive, 0.5779. So if there is an angle which is acute, look, sine 80 positive, cos 80 positive, tan 80 positive, all of them are positive. So if there's any angle theta which is acute, this will have all positive solutions. In the second quadrant, S means only sine is positive and the others are negative. Cos, tan, these are negative. So if you have an angle which is obtuse angle, if your angle is in the second quadrant which means like this, so this region, when your angle is between 90 and 180, then it would be called an obtuse angle. So if it is an obtuse angle, then only your sine value is positive. Look, if let's suppose I do sine 100, sine 100 is an obtuse value. So sine 100, look, it is positive. If I do cos 100, it is coming out negative. If I do tan 100, if it is coming out as negative. So in the second quadrant, only sine value is positive. If I take any other thing as well, if I take, let's suppose, sine 150 or cos 150 or tan 150, so you can see that sine has a positive answer, cos and tan has a negative answer. What is the answer right now? I'm not concerned with. I'm just showing you that if your angle is obtuse, then you would have a negative answer in for cos and tan, but positive answer for sine. Now for this thing, You can understand it as well, right? Only tan will be positive, and sine and cos values would be negative. And in the fourth quadrant, only cos is positive, sine and tan, sine and cos on the left one are negative, and sine and tan over here are negative. So this is something you need to learn, and for this thing you have this cast, CAST. This is like a, I don't know, mnemonic that will help you to memorize this. Now I can solve this. How? First of all, I would relate this cos theta 7 upon 10 with a simple right angle triangle. So this is your theta. Adjacent is 7, hypotenuse is 10. And I can use Pythagoras. 10 square, 7 square plus perpendicular square. So 100 minus 49 is equals to perpendicular square. So perpendicular would be 51, under root 51. This is the answer to your height, the perpendicular of this shape of this triangle. And so now if I want to find the value of sine theta will come out as, sine theta will be under root 51 upon 10, and tan theta would be equal to under root 51 upon 7. But now because it is in the fourth quadrant where only sine value is positive, sorry, cos value is positive. So this is positive, and the value of sine and tan, you would put the minus sign on your own. You have put it because the theta lies in the fourth quadrant, and in the fourth quadrant only cos is positive. The value of sine and tan are negative. So you found the value of the using the Pythagoras, and then you put in the minus sign yourself because the value of sine and tan in the fourth quadrant angle would always come out negative. Okay, try to think on this. Copy this down. This example is a very good one. And if you have any questions, ask. Okay. One more example on this one, and then we would connect this thing with another concept. Uh, okay. So now look, in this one, you have the value of sine is negative, and the theta is in the third quadrant, right? This is the third quadrant, right? Between 180 and 270. So this is the third quadrant. This region. This is where your theta lies, somewhere. And so first of all, you will make a right angle triangle to get the values, the other one. So theta, sine theta is zero point 0.9, negative 0.9 upon 1. So the opposite is 0.9 and hypotenuse is 1. Forget about the negative sign right now because you are trying to put in the sides of a triangle, and the length of the triangle cannot be negative. And now using hypotenuse, 1 square, 0.9 square plus base square. So 1 minus 0.81 is equals to base square. And so your base comes out as square root of 0.19. Something like that. And now you can find the value of cos theta. Cos theta and tan theta. This is square root of 0.19. Let me confirm it. Yes, it is 0.19. So okay, your cos theta would come out as under root 0.19 upon 1 adjacent upon hypotenuse, and tan would be zero point 0.9 opposite upon adjacent. And now because it is in the third quadrant using cast, only your tan is positive. Only the value of tan is positive. So you will keep the value of tan positive, and your cos value will be negative, and your sine was already negative because the theta was in the third quadrant where only tan is positive. So these are the solution. This is the answer. Okay. This is a very important concept. You will use this again and again later on as well, but this is the basic building. So copy this one down as well properly. Initially, this topic may seem a little bit difficult, and in the next class, definitely it would be the most difficult, I think, because you will learn a lot of different things separately, and by the end of the chapter, you will connect everything together, and everything is will connect as well, and eventually it will make sense. Initially, everything would be very scattered. You will learn separate things, and then you will at the end connect everything. So let's see. Now this is one logic that you have learned. Similarly, we will do 2, 3 more things separately, and then at the end we will see that everything would connect. Okay, so this is a little bit you will see connection right now. I'll try to connect what we have learned right now, but bear with me. So this is one thing that we learned. Now another thing this topic has, which is identities, trigonometric identities. We have only two of them over here. Only two. We have the first one, that is sine square theta plus cos square theta. It is always 1. Whatever the theta is, it will always come out as 1. And the other one is tan theta is equals to sine theta upon cos theta. You have to learn these. And these are only two of them, and you will use them so much that eventually you will learn this. But practice it properly. Now we can first of all, with the logic, with the things that we learned over here, we can show that these identities are true for any theta angle. For example, in this case, we have found these three things, right? The value of sine, cos, and tan value. We have found these, and if we use the same three values over here to prove, show that these are true. So we have these three things from the previous example we did, and now if I put in the things in the first identity, we have look sine square theta. Sine square theta would be minus 0.9 square, because sine value is negative 0.9. So sine square is negative 0.9 square plus cos square. So cos value is negative square root 0.19 square. Is it really equal to 1? So if we find this, look, a negative 0.9 square would become 0.81, and this would become 0.19. And look, this is coming out as 1. So this is correct. Similarly, for the second one, if we do tan theta, we have already found tan theta. It is 0.9 upon square root 0.19. And is it equal to the sine theta answer? Sine theta is negative 0.9 upon 1 divided by cos theta. Cos theta is negative square root 0.19 upon 1. So if we do the reciprocal, we don't know if right now it is correct. So if we do the reciprocal, negative 0.19 upon 1 multiplied by 1 upon negative 0.19. And you can see negative cancel out, and at the end you get the same thing. Left and the right side, it is equal. So look, with the examples that you did previously, you have shown as well. You have proved, you have seen for yourself as well that these identities are true. And these identities will work for any theta angle. You have to learn these. I have just shown you for your satisfaction. Okay, you won't need to show this in the exam. You have to just learn these and use these. I've just shown you to show you that these are true. So you can use a calculator as well. Whatever the theta value that you use. Look, sine, let's suppose it is sine 50 square plus cos 50 square, it is coming out as 1. So whatever your theta is, if it is 300, it's still 1. So it doesn't matter. You will always get the answer 1. But now you would use this, you will use these identity to show. They will ask you to prove the other identities using these. Prove the identities. How? Using this thing, they can give you prove the identity, this one, that cos square x upon 1 minus sine x, it is similar or equal to 1 plus sine x. This is showing the left side, it is equal to right side. Using the two identities that we have learned. So we can use the things from the above thing and then you replace it over here and we see if the left side is equal to the right side. So whenever you want to show what is the thing, you cannot move things, move terms from one side to another. So you won't directly put over there and multiply. Okay, you will keep everything to the left side and everything that is right side to the right side. You cannot move things around the inequality. This sign, similarity sign. Just secondly, you can simplify any side. You can start simplifying. You can either, if you want to simplify the right hand side or the left hand side using the identities, it's up to you. Both as well together. You start off by simplifying both sides together. You move it completely, and at the end somewhere you showed that the left side is equal to the right side. This also works. It's not necessary that you start simplifying this thing completely and change into exactly this form. And if it is also not necessary that you simplify this thing completely and you change it exactly in this form. You can go with both of them together as well. And at the end, if you see that somewhere along this working, that if the left side and the right side are equal, you can say that yes, you have proved that identity. But you will see some questions. This simplifying both sides together it comes in, I think, very difficult questions. One of the most difficult ones. The easier ones you can just start off with any one more complicated part. And the hint right now is start simplifying the more complicated part, because it is always easier to shrink something down than to open up this thing into a bigger, larger thing, more complicated one. So in this case, this one is more complicated than this one. So I would right now suggest that we try off with simplifying this part. And there are many methods that you will learn. There are many. This is pure algebra. Okay, it's algebra. If I ask you to do this, simplify the left side into the right side using the identities right now, you may take 1 page or 2 page or 3 page. Eventually, you will see that if you're using the proper algebra and everything, you will get the left side is equal to right side. And after enough practice, you will understand the pattern, how the questions are coming, and there are basic techniques that you will see that are again and again being used. Now the thing is, you have these identities, sine square plus cos square is equal to 1, and let me write this down again. and you have tan theta is equals to sine theta upon cos theta. Now you can play with these identities as well. You can manipulate them further as well. If you want, right now you can see you want cos square theta. So if I make cos square theta subject over here, I can move the 1 and I can move the sine square on the other side. So 1 minus sine square theta. So this means I can replace this cos square with 1 minus sine square. I can manipulate the identities, okay. So the cos square, I replaced it with 1 minus sine square x upon 1 minus sine x. Now another technique that you can use is by factorizing. If you factorize the numerator further, if I write down 1 square minus sine square like this, let me write it down the second another step. So if I write this down as 1 square minus sine x whole square, this is the third identity. Now I can simplify into 1 plus sine x and 1 minus sine x. And you can see in the denominator you have the same factor, 1 minus sine x. So 1 minus sine x and 1 minus sine x cancel out. And you are left off with 1 plus sine x, which was already on the right side, 1 plus sine x. So you will say hence shown. So this factorizing, this is sometimes this comes in handy. Otherwise, there can be some other method as well. Okay, there isn't only one method to change the left side to the right side or the right side to the left side. You can do it in 3 pages as well. Eventually, you will get the answer. So that would also be correct, and this would also be correct. So it's just up to you how much practice you have done and how quickly can you see the how can you change the left side to the right side or right side to the left side. So this is the first part. Always you will see in the past papers as well. You will again and again the first part will be the same thing like this. They will ask you to prove the identity, and then you will use the identity that you have proved in the second part further for further users. So you can copy this one down as well as an example. We'll do some more identity proving using only the two that we have learned. Sorry. 1 minus cos square x upon sin x cos x. We have to simplify. You can see the more complicated part over here is the left part, left side. So what can we do? So 1 minus cos square upon sin x cos x. Okay. 1 minus cos square. You can replace. Look, if I manipulate this thing further, if I make sin square the subject, so this will be 1 minus cos square. This is pure trial and error. Trial and error. Okay, you cannot directly have the answer in the first time. You check it. You try for something. You input that. You use it. You try to simplify it. If it is leading you to the answer, good. If it is not, try something else. Okay, I have done this so many times for so many years that I directly see the question and I get in my idea and I get the idea of how to solve it. The steps, complete steps eventually. But you have to go through this thing. Okay, it's not very easy the first time. I know the first time when I did also, it wasn't as easy. I had to do a lot of practice and I had to waste a lot of pages as well. But eventually, you try something. If you're not getting the answer, you try something else. Then you try something else. Then you try something else. You will eventually get to the answer. So look, in this one, look, sine 1 minus cos square. I replaced it with sine square because I've used identity. So now this sine and this sine square cancels out. So you have sine x upon cos x, which will be equal to 10x or not. Sine x upon cos x, we have it is the 10x. So we have shown, hence proven, or hence shown. This is your answer. That's it. Because I am doing this right now with you people, it seems very, very easy. Okay, I'll give you some practice questions. Some of them won't be as easy. You would try something, you won't get to the answer, you would try something else, or you would try something else, and then again, then again, then again. Eventually, you will get to the answer. But this is something I enjoyed in my time. This is pure algebra, simplification algebra, and then converting one thing into another form. Okay, this is it for today's class. You can copy it down. I'll stop the recording as well.